We're going to continue on in Unit 3 and discuss how to balance chemical reactions. Um, so I have given you a sentence that describes a chemical reaction. Sodium bicarbonate is heated, which produces sodium carbonate, water, and carbon dioxide. So we learned in Unit 2 how to write formulas given names. So of course, I'm going to ask you to remember that, right? No, but seriously, chemistry is a cumulative science, and so every unit you build on the previous unit. So believe it or not, you're actually studying for your final by continuing on with each unit. Okay, so let's go back to this sentence. Sodium bicarbonate. Remember that sodium is Na plus, bicarbonate is HCO3. The formula for that would be NaHCO3. Reactions follow the format that reactants are written on the left side, and then there's the reaction arrow, and then products are written on the right side. So sodium bicarbonate is heated, which produces. So this tells you that there's going to be an arrow, sodium carbonate, water, and carbon dioxide. So sodium bicarbonate is a reactant, while sodium carbonate, water, and carbon dioxide are all products. Okay, so you have sodium bicarbonate, arrow. Okay, so sodium carbonate, sodium's Na plus 1, carbonate, I'm sure you knew that, right? Do the cross and drop, and you end up with Na2CO3. So that's going to be one of your products. You get water. We all know water sometimes. And then carbon dioxide is CO2. Now, what we're going to cover in this class or in this lecture is how to balance these reactions. So the one thing to do is to think of the reaction arrow as like an equals sign in math. So whatever's on the left side of the arrow must equal whatever's on the right side of the arrow. So I look at my sodium. On the left, I have 1, and on the right, I have 2. All right, that's not balanced. I look at my hydrogen on the left, hydrogen on the right. So I have 1 on the left, 2 on the right. 1 carbon, 2 carbons, 3 oxygens, 3, 4, 6 oxygens. So it's not balanced. So we're going to have to take care of this. So when you first start balancing chemical equations, a lot of students are frustrated. They don't get it immediately. And I get that. It does take practice to get these. A lot of times it's like watching a tennis match. You look on one side of the court, you look on the other side of the court, you look on one side of the, so it's like constantly watching the ball. But practice makes perfect on these, and usually I'll get students who, they'll struggle, 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 and then all of a sudden it clicks, and they're like, I like balancing equations. I get it. It makes sense. I know when my answer is correct, and I know when it's incorrect. So, okay, this equation is not balanced. We're going to balance it on the upcoming page. So on the next next sentence I've given you, I want you to write an equation for it. So plumbous sulfide plus gaseous oxygen yields solid plumbous oxide plus gaseous sulfur dioxide. And a lot of you might be thinking, what did she just say? I have no idea what she's talking about. I'm so over this lecture. If you have no idea where to start, just put your arrow. That you put your line in the sand, and now you know you have your reactants and you have your products. So read the sentence again. Plumbous sulfide plus gaseous oxygen yields. This is your arrow. Yields solid plumbous oxide plus gaseous sulfur dioxide. And if you actually have to write the names of these and then come up with the formulas, that works too. So break each one of these down. So you have plumbous sulfide here plus gaseous oxygen. Remember that oxygen is one of those molecular elements. It's a Hofbrinkel, right? it occurs in twos. So it's like that. Plus solid plumbous oxide plus gaseous sulfur dioxide. Okay, sulfur dioxide, I get that one. Now these plumbous sulfides, plumbous oxide, going to require a little work. Plumbous is Pb. Us is the +2. Sulfide is -2. So you get PbS. Plumbous Pb2, oxygen 2 minus, so it's going to be PbO. Is this balanced? Pb, yes. Sulfur, sulfur, yes. O2, O2. Wait a second, 3 oxygens. That's not balanced. So we're going to have to learn how to balance that. But the underlying equation is correct. We have the reactants and the products on the right side, and we have the correct formulas. All right, so let's go to this last equation. Lead 2 nitrate plus potassium iodide yields, here's your arrow, lead 2 iodide plus potassium nitrate. So I want you to hit pause. Try to write this equation on your own. Okay, so hopefully you got PbNO32 plus Ki gives you PbI2 plus KNO3. Now, is this equation balanced? No. We will learn how to balance it. And in fact, I'm just going to go ahead and balance it for you right now. 1 lead, 1 lead. 2 nitrates, nitrate stays together. 2 nitrates over here. Now, this has to do with the law of conservation of mass, that we have to have it equal on both sides. So I can't change the formula of potassium nitrate. That would totally mess everything up, right? You're now playing with the chemistry to get this to balance. That's not going to work. So you need to balance with coefficients. So I can put a 2 in front of this, and now I have 2 nitrates and I have 2 potassiums. So I need to go back to my potassiums and put a 2 here. So it's even more like watching a tennis match. And now I have 2 potassiums, awesome, 2 iodides, and I have 2 iodides over here. So my coefficients for this reaction are 1, 2, 1, 2. And 1, 2, 1, 2 can't be further simplified. If it were 2, 4, 2, 4, then it could be simplified. Divide by 2, right? Okay. Let's go to the next page, and we'll discuss more balancing, and we'll fix those that aren't balanced. All right, so the law of conservation of mass states that mass is neither created nor destroyed in chemical reactions. Okay, so that's why we need to balance these equations. So are the equations on page 6 correct? No. They're defying the law of conservation of mass. So we need to fix that. And the way we can fix that is with coefficients, not by changing formulas, but with coefficients. Now, the first few times that you balance a chemical equation, it can be kind of painful and tedious. But then it becomes kind of addictive, like puzzles. So here's what I recommend when you're first learning how to balance chemical equations. Underneath the chemical equation, write down the participants in your chemical reaction. So I have sodium here, I have hydrogen, I have carbon, I have oxygen. You don't need to keep track of any other atoms because they're not involved in this chemical reaction. So don't make it harder for yourself. So what I'm doing now is I'm just going to tally what's going on. So I have 1 sodium here, 2 sodiums here. And I like to use the tally sticks. Some students just like to write 1 and 2. That's fine. You might see why I use the tally sticks coming up. It's actually one of my students who showed me it's easier to use tally sticks, which is awesome. Okay, hydrogen, 1, and then I have 2 hydrogens here. carbon, 1, and then I have 2 carbons here. And then I have 3 oxygens here, and 3 plus 1 gives you 4, plus 2 gives you 6. Now, you have to watch me with these tally sticks. A lot of times I like to make my group of 5 a group of 6. So you've been warned. Okay. Um, since these are not equal, we have a problem. You are violating the law of conservation of mass. So I need to do something to fix this. And sometimes when you keep track of it this way, it's really easy to see. Okay, if I multiply 1 times 2, I'll get 2. 1 times 2, I'll get 2. 1 times 2, get 2. 3 times 2, I will get 6. So here's the solution. I put a coefficient of 2 in front of that bad boy. And now I have effectively solved all the problems. I have balanced that equation with just one coefficient. So this equation is currently balanced. I don't need to do anything else. I can walk away. Sometimes I have students who really don't like to leave blanks, and that's fine. What you can do is you can put a 1 here. What you don't want to do is put a 0. If you put a 0, then you'll really mess with chemistry, and that would not be good. Okay, so you can leave it blank or with the 1s. I think I've said this a few times, but it never hurts to say it again. Balance equations by changing coefficients in front of the compounds, not by changing the chemical formulas. Trial and error. Trial and error. Okay, so this takes a lot of practice to master. And what are we going to do now? Practice. All right, so this first one, I put a line where the arrow is. I'm going to tally up everything. I'm going to change this. This will make it a lot easier. I'm going to write water as HOH, and I'm going to keep track of OHs, not just O's. I'll still keep track of my hydrogens, but when you see an OH together, I want you to tally those together in here. Okay, so let's go. Hydrogen, 2 hydrogens, 1 hydrogen. Sulfate, 1 sulfate, 1 sulfate. Hydroxide, 1 hydroxide, 1 hydroxide. Sodium, 1 sodium, 2 sodiums. All right, so I see a problem with my sodiums. So I can multiply this one by 2, make that equal. When I put a coefficient of 2 in front of that, I have also impacted the hydroxides. So I'm also doing that. So now that is not equal. So I need to go over here and say, all right, I need to have 2 hydroxides. How would I fix that? Well, how about if I multiply those by 2, multiply that by 2, those are equal, but I've also impacted the number of hydrogens. So the number of hydrogens is going to be multiplied by 2, and that will be equal. So 1 sulfate, 1 sulfate, that's still good. So that's balanced. And again, with the blanks, you can leave them blank, or you can put a 1, 1, 2, 1, 2. At the end of a reaction, when you've balanced it and it's all good, you want to check if you can simplify the coefficients. So if I had something like 2, 4, 2, 4, I would simplify that to 1, 2, 1, 2. Okay. All right, let's go on to the next one. Do the same thing. All right, magnesium, 1 magnesium, 1 magnesium, 1 oxygen, 3 oxygens, 1 iron, 2 irons. And so let's see, our oxygens and our irons are off. Let's multiply this one by 3. So now that's equal, but I need to multiply the magnesium by 3. So that's not equal, so I need to put a 3 here. Now I need to do my iron. That's equal. So everything is equal now. 3, 2, 1, 3. Can I simplify that any further? No. If it was 6, 4, 2, 6, then I could. But right now I can't. So those are my coefficients, 3, 2, 1, 3. All right, let's go to the next one. I'm hoping that you're having a little bit of fun. Maybe. Not yet. A little bit more practice needed. That's okay. All right, so 2 golds, 1 gold, 3 sulfurs, 1 sulfur, 2 hydrogens, 2 hydrogens. All right, so I need to fix what's off? My golds are off. And my sulfurs are off. So let me fix my sulfurs first. I'm going to multiply this one by 3, make that equal. I've also changed the number of hydrogens. So it's 6. So I need to put a 3 here. Now that's equal. Now the only thing that's off is my gold. This is an easy fix since it's just gold over here. So I just need to multiply it by 2. Boom. 1, 3, 2, 3. Okay. All right, so maybe this is getting a little bit easier. I have more practice problems because practice makes perfect. All right, so in this one usually throws students for a little loop. And I'll give you a hint why. The hydrogens are in 2 places in your products. All right, so let's tally. Tally, tally, tally. 1 phosphorus, 1 phosphorus. 5 chlorines, so watch me here. 1 chlorine. 2 hydrogens, 3 hydrogens, 1 oxygen, 4 oxygens. All right, so let's fix our oxygens. So I'm going to multiply this by 4. Wait a second. That also multiplies it by 4. Okay, and I did something wrong over here. I even made a mistake here. So you have 3 hydrogens here and 1 hydrogen here. So I warned you about it, and then I missed it. Okay, so this is going to be equal to 8. Now this is equal, but that's not necessarily equal yet. All right, so somehow I need to get 3 and 1 equal to 8. How am I going to do that? Well, I can multiply this by 5. What is 5 plus 3? That is 8. So now I have 5 hydrogens here, 3 hydrogens here. That equals 8. I'm also multiplying the chlorine by 5. So I need to add that, update my tally sheet, my budgeting, if you will. And now check the other things. Phosphorus is good, hydrogen's good, everything's good. So the coefficients are 1, 4, 1, 5. Alrighty, so this next equation, go through and do your tallies. Okay, is that what you got? So I'm going to balance. I'll go ahead and balance my aluminums. So that's equal, but I've also changed the chlorines. So that is not equal. I need to, 2 times 3 is 6. So I need to put a 6 here. And that's equal. Now I have 6 hydrogens. So I need to multiply this by 3 in order to make that equal. 3 sulfates. Oh, and I need to multiply that by 3. Now we're all good. So you'll get to a point with these balancing reactions that it just kind of flows. And you get really good at looking back and forth. And a common mistake that students make is they don't distribute out their coefficients. Like you remember to change the number of hydrogens, multiply that by 3, but then you don't remember to multiply the sulfate by 3. And you'll get better at that. Like I said, it just takes practice and kind of going back and forth. And usually I'll find there's some students that get it right away, and there's other students who don't get it right away, and then there are some students who can explain how to do it very easily. So it just Just depends on where you are, but don't get discouraged. Keep working on it. Okay, this is one of the equations from page 6. Okay, so one lead, one sulfur, 2 oxygens, 1 plus 2 oxygens. All right, so I'm going to multiply my sulfur. It's hard to figure out where to go because your lead and your sulfur are balanced. What's off is your oxygens. And you are in a very difficult spot right now because you're in an even odd dilemma. You have an odd number of oxygens on the right and an even number on the left. And as long as you have this, you're never going to be balanced. Okay? So what I want you to do is to try to make your odd number even. So if I multiply this one by 2, that's going to be 4 plus 1. That'll still make it odd. But if I multiply this one by 2, then I will have 4. And that will be much easier to balance. So I can balance this one by putting a 2 in front of that. Now by putting a 2 in front of this, wait a second, I'm going to hold off on this one. I forgot distribute. To distribute. 2 PB. Okay, so, and I've also multiplied by so that's good, but my sulfur's off, so I need to do that. Okay, so now I have 2 times 2, 4, plus 2. This is equal to 6 there. So then I need to multiply that one by 3, and it's equal. So it's kind of a weird problem, but you get better at these. Usually what you want to do is leave the element that's in both of your products to the end to balance, and then it will work out easier. So it was kind of hard to get started on this one, but once you got going, you realized, okay, so 2, 3, 2, 2, can that be simplified? No. So that's as simplified as it's going to get. All right, so on the next page, I have chemical equations that I want you to practice. I want you to hit pause and practice these. And when you come back, I will go over the answers. Okay, so question 1, 1, 3, 2. Now you will get to the point where you don't need to tally up as much. If you get to a tricky one, after you've mastered it, you might need to tally up, but by and large, you'll be able to go back and forth and keep track of it and update it. Okay, 2 is 2, 2, 3. 3 is 2, 1, 2, 1. 4 is 2, 1, 2. 5 is 2, 1, 2, 1. 6 is 2, 3, 6, 1. 7 is 1, 2, 1, 2. 8 is 1, 3, 1, 3. 9 is 2, 1, 2, 1. So if you're still struggling with balancing chemical equations, don't despair. Keep practicing. Do your homework problems. It will come to you. And it's definitely a skill that will be used and carried on in further chemistry classes. So make sure you get it now. All right, that concludes this lecture, and I'll see you next time for more Unit 3 lectures.